Good evening, folks. Brian here, Geomagnetic Earth Watch, Friday, January 20, 2023. So I want to go through a definition, all the definitions of earthquake meetings, as there's always going to be new people on the block moving into the neighborhood who don't understand some of what I say. So I'm just going to run through briefly a definition of different things such as fulcrum points and antipodes and things like that. I'm going to keep it simple. So often I will say an antipode earthquake or an antipode point. An antipode is a point directly on the opposite side of the earth of an earthquake. So if this is the earth and we have an earthquake here, that seismic energy will travel through the center of the earth and come out on the opposite side antipode or within 30 degrees. It may be deflected slightly when it comes through the core, through the other side of the earth. So an antipode earthquake is an earthquake on the other side. The parameters, however, this was based on a study in the University of Oregon. They looked at 44 years worth of earthquakes. I believe it was over 5,000 earthquakes. And they found out that an earthquake of magnitude 6.5 or larger can result in an antipode earthquake minus about 1 magnitude. So it will lose some energy as it's traveling through the earth. And again, within 30 degrees of an antipode, or what I would say finding the weakest point, a fault line or volcano. So with today's description, for example, of the deep Argentine earthquake, the 6.8 at 610 kilometers deep, I believe, falls within the parameters of that seismic energy traveling through the center of the earth and coming out on the other side. The other side being, the exact point is actually a region between China offshore and Philippines. So you take a point where you have most of that seismic activity in that region. Of course, it's Philippine because of the subduction zone. Therefore, I say we can expect an antipode response. Let's say around 5.3, 5.5. The timing of antipode earthquakes are uncertain. I've seen it happen actually within minutes. So let's say between 8 and 72 hours, depending on what's going on within our planet. Now, this is not covered in their study. It's one of my own theories. If we have that energy working its way through the center of the earth, well, what if we have another larger earthquake and we'll deflect that energy? Therefore, we're not going to get an antipode response. The Argentine earthquake, let's say another earthquake, right? So that's an antipode earthquake, a point on the opposite side of the globe. And quite often, this is proved correct. There was a recent earthquake in the Galapagos regions, between the Galapagos Islands and Ecuador. That was the antipode from a previous larger earthquake somewhere around in Indonesia. An antipode response. Next, let's talk about fulcrum points. Fulcrum is a midway point between two earthquakes. So if we have an earthquake up here, and within a certain time frame we have another earthquake down here, that fulcrum point is my chin, a point in the middle. So that seismic energy will spread. And this seismic energy will spread, meeting in the middle. And I'll give you one very good example. In the summer of 2021, we had the 8.2 earthquake in the Alaska Peninsula, which actually came in as a 9.5, but they didn't want anybody to see it, so they just put it as 8.2. Those aftershocks continued to magnitude 7s. Shortly afterwards, there was an 8.2 earthquake in the South Sandwich Islands. So Alaska, 8.2. South Sandwich Islands, 8.2. Great distance. What happened a couple of days later, in the middle point in the Caribbean, Haiti, was the 7.4 or 7.6 earthquake. The energy spread from Alaska. This energy spread from South Sandwich Islands, met in the middle in the Fulcrum Point, and caused the earthquake in Haiti. Fulcrum Point earthquakes. Doesn't always happen, but if people understood the manner and pattern of earthquakes, sometimes lives can be saved. Now, deep earthquakes. The theory in the past, and this was originated by Dutch Sins, so credit goes to him for this explanation, is that a deep earthquake sometimes can result in a larger, shallower earthquake as that seismic energy rises and the magnitude increases. Sometimes. That has not happened many a times over the past couple of years, which is why I no longer follow it. So the theory from deep earthquakes is either one, sometimes we can have a larger, shallower earthquake, the energy comes up, or an equal spread of that same magnitude earthquakes. And that could lose a magnitude. So if we have that deep 6.8 earthquake, Argentina, it could result in a larger 8.2, 8.5 even earthquake, shallower, or that energy will spread out and it will have an equal spread of, say, 6s in the area. Next, we talked a lot about the effects of cosmic rays on the human brain, giving us headaches and making us go cuckoo. Especially one guy on the other side in England right now is going a little bit cuckoo, Gene. But it does also have an effect on our planet. So cosmic rays, when they enter our atmosphere, interacts with the atmospheric atoms, the nuclei of the atoms actually, and creates a secondary showering particles called muons. These muons do penetrate deep through the Earth's crust. And when interacting with silica-rich magma, heats up the magma, causing a rise in pressure from the magma. Remember those mantle plumes I'm talking to you about, which puts a pressure underneath the underside of the Earth's crust. And that pressure is going to find the point of least resistance, or the weak point, fracture zones, for example. So with the earlier video from Nemesis Maturity, of that humongous large filament eruption from the southwest region of the sun, hundreds, if not thousands, if not tens of thousands, the size of the Earth, the filament eruptions, which ejected a large CME, which fortunately, so far we think most of it's not going to hit us. A CME, coronal mass ejection, contains billions of tons of the highly charged particles, plasma, mostly protons, some electrons. And in the again, those can penetrate the Earth's crust, cause bubble nucleation of silica-rich magma, rising pressure underneath the Earth's crust, earthquakes. So we can forecast the possibility of earthquakes depending on which side the sun is when that CME hits. And finally, let's stick with muons and let's move on to earthquakes. Excuse me for a minute. So there was a Japanese study, the effect of cosmic rays, or rather the secondary particles, muons, interacting with the magma chambers of volcanoes. And they used the eruption of Mount Pinatubo as an example, which was preceded by a cosmic ray storm, or solar storm, CME impact. And again, heats up the magma inside the magma chamber, resulting in volcanic eruptions. So I just want to give you some explanations of some of the terms that I use almost every day now. Antipode, opposite side of the Earth. If the earthquake is larger than a 6.5. Fulcrum point, a point in between two earthquakes within a relative same time period. The energy meets in the middle, causes a third earthquake. Deep earthquakes can sometimes result in a larger, shallower magnitude earthquake or a spread of equal magnitude earthquakes. So in the case of Argentina, there could be a spread of slightly smaller earthquakes, Argentina, Peru, maybe Bolivia. And there you go, folks. That's about it for earthquakes. I just wanted you to have a better understanding when I start talking about these things. All right. So until our next earthquake, we'll see you later.